In this video, we are going to learn how to calculate the relative atomic mass of an element from its isotopic abundances. If we consider carbon, its relative atomic mass is very close to 12 atomic mass units. This is because in nature, 99 atoms out of 100 atoms of a carbon sample are carbon-12 isotopes. Another way of saying this is that carbon-12 has a 99% isotopic abundance. However, not all relative atomic masses of elements weighted this way. Chlorine, for instance, exists as two isotopes, chlorine-35 and chlorine-37. How many protons and neutrons do you think each chlorine isotope has? Remember, the mass number of an isotope is equal to the number of protons. It has plus the numbers of neutrons. Pause and select one of the following options. Use the chemical symbols to help you work this out. Both chlorine-35 and chlorine-37 have 17 protons, but the chlorine-35 isotope has 18 neutrons, whereas the chlorine-37 isotope has 20 neutrons. The answer was A. Did you get it right? In nature, out of 100 atoms of chlorine sample, 75 of those atoms are chlorine-35 isotopes and 25 of those atoms are chlorine-37 isotopes. For you to be able to work out the relative atomic mass for chlorine, you have to multiply the mass number of the isotope with its abundance percentage and add these products together. This gives the total mass number of the isotopes. Using this data, you can calculate the total mass of chlorine isotopes using their abundance and mass numbers. Pause, think, choose and continue when you're ready. The answer is B. You have to multiply a 75% abundance in the chlorine-35 isotope by its mass number 35. You then have to multiply a 25% abundance and a chlorine isotope by its mass number 37. When added together, this gives a total of 3550. The final step is calculating the relative atomic mass is to divide your answer by 100. This is because the abundance are given as percentages. This means chlorine has a relative atomic mass of 35.5. Here is a challenge. From the following data, calculate the relative atomic mass of uranium. Pause and continue when ready. Make sure you write your working out down as you do the calculation. The correct answer and working out is displayed on the screen. Remember, you then have to divide this value by 100. That gave you 237.99. Did you get it right? In summary, the relative atomic mass is the average weighted for the isotope of a particular element. To calculate this, you need to multiply the relative abundance by the mass number of the isotope. Add these products together for each isotope and then divide the total by 100. And that's how you calculate a relative atomic mass of any element from its isotope in the periodic table.